Okay, so this is the quickest way I figured out how to do it, and that's by using doing 9 long divisions. So the first thing I'm going to do is list out the multiples of 72 up until sort of like a reasonable point. So I figured somewhere near around 4 digits. So I just did 72, 144, and so on and so forth. So this does two things. It confirms that the numbers will only ever end in 2, 4, 6, 8, and 0, which it does. So I know the last digit's going to be 0, 2, 4, 6, or 8. And now I'm going to do all the combinations. So I list out all the combinations here based on the first number. So I'm going to take this first set here, the 1100s, 2100, 3100, 4100, 5100, and up till 9100. And I'm going to do a long division on the first one. So when I do the long division on the first one here, it goes in once 72, so that the remainder is 38. And if I carry down the 0, it's going to be 380. And if this was the 2, 4, 6, or 8, it would be one of these numbers. And what that gets me is I know that this number, if it was to divide evenly with a remainder of 0, has to exist as one of these numbers. So in reality, I could stop right there because none of these numbers start with 38, so I don't even have to bother evaluating the rest of the series. So when I do that with 2100, the remainder is 66, and none of these start with 66, so I don't even have to bother going on, because I know the remainder won't be 0 if it's not a multiple. If the last portion of this long division isn't one of these numbers. So the one that is one of these numbers is 50. So imagine if I did 4100 here, and this number is 50. The remainder is 50. I carry down the 0, 2, 4, 6, or 8. Well, I know this starts with 50. I look up here really quick, and I see, okay, this starts with 50. So now I could continue doing the others. And if I do the others, I'll notice, okay, this one is 504. So 504 does evenly become one of the multiples of 72, so meaning the remainder is 0 if it's one of the multiples of 72. So I know right away that that 4104 is a perfect multiple here. But if I quickly do the other ones, 6 is up here as one of these, but I know it's not 62. I know it's not 60, 62, 64, 66. So I could rule out this series. Same with 34 here. 62, 18. None of these numbers start with these numbers, other than the 50. So right away I know I don't have to move on. But that's a quick way of doing it, where you only have to do 9 long divisions, and you only have to do the first portion of the 9 long divisions to get the leading digit, because once again, the last digit when you carry it down is 0, meaning this would be 380, 382, 384, 386, 388. So once you know this, and it's not in any of these, then you don't even bother. So, but that's really it. That's the fastest way I could think about doing it, and that's it. Hope this wasn't too confusing to explain it.